We're on problem 79. A small business owner must hire seasonal workers as the need arises. The following list shows the number of employees hired monthly for a 5-month period. Okay, so we hired 4 in the first month, 13 in the second month, so on. If the mean of these data, remember data is a plural, I always say this data, but if they correctly say, if the mean of these data is approximately 7, so the mean is just the average, right? So they're saying the average of these numbers is 7. Fair enough. If you add all of these up and divide by 5, you'll get approximately 7. What is the population standard deviation for these data? So, population, and I'll make a statistical playlist one day where I talk about the difference between a population standard deviation and a sample standard deviation, all of that. But the population standard deviation, it's just so you have an intuition, it's a measure of, on average, how far are each of these numbers from the mean. And it's not exactly the average of how far they are from the mean, but I'll show you that in a second. It's actually the square. It's the square root of the average of the square distances of how far each of these are from the mean. And that might sound crazy for a second, but when we actually work it all out, the math isn't too bad. So what we'll do first is figure out the variance. The variance. And that's the notation for the variance. And the standard deviation actually is just the square root of this. So it's easy. If you have the variance, it's very easy to figure out the standard deviation. But the variance, and just to give you the intuition, it's equal to the average of the squared distances. Squared distances. From the mean. From the mean. From the mean. So essentially, I say, okay, how far is 4 from 7? Oh, it's 3 away, and I square it. I say, okay, that the square distance is 9. The square distance here, let me figure it out. So let's actually write them down. 4 minus 7, let me actually calculate it. So I'll do it here. 4 minus 7 is minus 3. If I were to square that, I get 9. So the square of the distance from 4 to 7 is 9, right? So that's a square distance. So the square of the distance from 13 to 7. See, they're 6 apart. You square them. And because we're squaring, it doesn't matter if we do 7 minus 13 or 13 minus 7, because a negative times a negative is a positive. So anyway, 13 minus 7 is 6. That squared is 36. Then I have 5 minus 7. That's minus 2 squared is equal to 4. Then I have 6 minus 7. That's 1. Negative 1 squared is equal to 1. And then I have 9 minus 7. That's 2 squared is equal to 4. So the 9 is the square of how far 4 is from 7. 36 is the square of how 13 is from 7. So each of these are the square distances, right? Of each of the data points from the mean. That's where we got the 7 from, the average of these numbers. Now, we said the variance is the average of the square distances. So it's just the average of these 5 numbers. So what's the average of these 5 numbers? It's going to be 9 plus 36 is 45, plus 4 is 49, plus 1 is 50, plus 1 is 54. So it's going to be 54 divided by 1, 2, 3, 4, 5, divided by 5. So the variance is equal to the average of the squared distances. And that's what? 10 and 4/5 is equal to 10.8. So that's the variance. And they don't want the variance. They don't want the population variance. They want the population standard deviation. Well, that's just the square of the variance. And you can see, since you're saying the square of the square distances, it kind of becomes close to the average of the real distances. But it's actually not that, and I don't want to confuse you right now. For the sake of this problem, let's just take the square root of this. So the standard deviation is just equal to the square root of the variance, which is equal to the square root of 10.8. And what is that? Let's see, 3 squared is 9, 4 squared is 16. So the square root of 10.8 is going to be pretty close to 3, between 3 and 4, but a lot closer to 3. And if we look at all the choices, the only one that even comes close is this one. And I think if you actually found the square root, it's actually very close to 3.3. Next problem. Next problem. James found the mean and standard deviation of the set of numbers given above. If he adds 5 to each number, which of the following will result? All right, if you add 5, the mean will be multiplied by 5. No, that's not right. Because if you add 5 to each of these numbers, the mean will just become 5 bigger, right? You're kind of just shifting over the center to some degree, where you're measuring the center by the average over 5. Actually, I could actually show it to you. If I said 3 plus 5, and I'm going to add that to 6 plus 5 plus 2 plus 5, right? I'm adding 5 to every number. Plus 2 plus 5, plus 1 plus 5, plus 7 plus 5, plus 5 plus 5. All of that divided by, there's 1, 2, 3, 4, 5, 6 numbers, right? All of that divided by 6. This is the same thing as, let me write this. This is if we, we can get rid of the parentheses. All we're doing is adding. So that's the same thing as 3 plus 6 plus 2 plus 1 plus 7 plus 5. I just took the first terms in each of these, right? Plus, how many 5s do we have? 1, 2, 3, 4, 5, 6. Plus 6 times 5. All of that over 6. Well, this is going to be, so this is equal to, let's see, 3 plus 6 plus 2 plus 1 plus 7 plus 5 over 6. Let me scroll down a little bit. Plus, what's 6 times 5 divided by 6? Well, that's just 5. So this is the average of the original set of numbers, right? And now, when you add 5 to all of them, the average of all of them combined is just going to be the original average plus 5. So you're just shifting the average to the right. So this is not right. You're not multiplying the mean by 5. You're just adding 5 to the mean. That's not right. The standard deviation will increase by 5. Well, in the last video you saw that the standard deviation is the square root of the variance, but both of them are a measure of kind of the average distance of the numbers from the mean or from the average. So even if you shift everything by 5, right? The mean shifts by 5, all of the numbers shift by 5. Their distances from the mean aren't going to change, actually. The standard deviation actually won't change. So this isn't right. The standard deviation won't increase by 5. These numbers aren't going to become further away from the average. So that's not right. The mean will not change. Well, no, we know that the mean will change. I just showed you that the mean will actually increase by 5. Right? When all the numbers are increased by 5. So that's not right. So we already know that D is probably the answer, but let's make sure. The standard deviation will not change. Right. In general, the kind of the average dispersion, or how far on average the numbers are away from the mean, won't change. All the numbers are going to increase by 5, and the mean is going to increase by 5. So how far the numbers are from the mean, or their variance won't change, kind of the square of their distances won't change. And if the variance doesn't change, then the mean won't change. So the answer is definitely D. And we're all done. See you in the next playlist.